Okay, so for this lecture series, here are the contents. First off, I will going to share some market overview and update on what's happening on the industry, specifically on the radio access network. What are the current trends? What are the latest uh, advancements in terms of how do telco operators and suppliers adapt, and also what are the current deployments in terms of the mobile networks around the globe. And also, I'm going to share some hot topics for 2024, including the 5G, some updates on 5G evolution. How is the industry specifically coping up with the deployment of 5G? And also, I think this is one interesting topic that I would like to share with everyone is on the evolution of the private wireless networks and the demands, particularly on the top industries from the vertical segments that we have also around the globe. And of course, last but not the least, the current developments of Cloud RAN and ORAN. And of course, we will wrap up with some key takeaways. Yeah. So for your questions, I will try to answer that briefly. Just feel free to type in your questions in the chat box, or also later on I will I will share my contact details for us to connect in the future. Okay? Yeah. So to begin with, in terms of what is currently happening now, I think this is a very good slide showing the current status of 5G. So from industry analysts and also from our own analysis as well, from Nokia, we are seeing that 5G has the fastest uptake of any mobile technology so far. So compared to the other Gs, 3G, 4G alike, the market adoption of 5G by far is the fastest among all of the generations of the wireless cellular technologies. And that being said, as you can see right here in the screen, since this market capture here is showing how many operators have deployed 5G across their networks since Q3 2023. So we have actually added around 10 operators, or around already 300 operators have launched 5G across 113 countries globally. And in terms of devices, there has been a lot going on in terms of the chipsets, the handhelds, smartphones that supports 5G technology as well. And out of that, around 2,300 devices announced, around 1,000 of them are SA capable or standalone capable. But I think what's also, in the perspective of coping up in terms of the standalone architecture is the adoption of the 5G SA. So in terms of the current deployments that we see around the globe, most of the operators are still operating on NSA mode or non-standalone. And as you can see right here, it's just a mere 46 of operators globally are already in 5G SA. And I think this is where there's a lot of coping up to do in terms of the advancements or the adoption to SA, because as you may already been aware or studied, there's a lot of differences in terms of the 5G architecture when it comes to NSA, the non-standalone, and the standalone mode. And fortunately, there's also quite a lot of customers or operators investing in 5G SA. But as you can see in these two boxes here, since the third quarter of last year, there hasn't been any addition of operators around the globe that has launched 5G SA. So in that sense, This is primarily because of most of the operators have invested heavily in NSA mode. Of course, 5G will definitely work initially with the help of 4G LTE. That's why what we see is that customers or operators will likely take off their 5G deployments from their LTE network as a baseline. Yeah. But in terms of 5G connections, as you can see right here in the lower box, in the blue box here, surprisingly, again, 5G connections, we have reached around 1.5 billion connections or subscriptions in 2023. And it is forecasted to reach around 2 billion connections by end of 2024. And out of the total population, or in terms of the global population, the footprint of 5G has already reached around 38%. Yeah. And based from analysis Omdia, in terms of the mobile subscriptions and revenue forecast from 2021 to 2028, we can see that in the next 4 years, 5G will now be almost equal to the number of subscriptions as 4G. So what we're seeing here is that there's a lot of potential in terms of 5G, and also that's what the standardization has envisioned it, that in this decade, 5G will in fact take over, or not really take over, but eat up a lot of the traffic from the 4G networks around the globe. And again, if you ask what is currently the main application or use case of 5G, it's still enhanced mobile broadband. Most of the operators globally are still using 5G to offload the traffic from their 4G layer or 4G network in their networks. Yeah. And having said that, in terms of the global data traffic growth, the 5G momentum continues. In terms of the traffic driving markets such as China, India, and the US. So these are the top three countries who are really driving the traffic globally. So not only in terms of population, but China still holds the #1 spot with the highest number of 5G traffic in the market. And if you ask what are also the drivers behind the adoption of 5G, is again the digitalization, and also the promotion of digital devices. We know, of course, China also has a huge market in terms of IoT devices, handhelds, furnitures, and even appliances connected to their wireless cellular network. And also one of the major factors driving 4G adoption is the affordability of smartphones and the focus on rural areas. So in other markets, what we see is that, especially in India, they're now beginning to focus their 5G deployment on rural areas, even those that are very remote. So they're now trying to capture the subscriber base in the remote places. Yeah. And also, in terms of the global data traffic, the blue bars here indicates 4G. And again, based from forecasts, what we are seeing is that in 4 years' time, in 2028, as you can see, there is an expectation that 5G traffic will constitute around 80% of the total global data traffic. And LTE, the legacy Gs, the 2G, 3G, and 4G, will take up to 20% of the global data traffic. And I think another interesting thing to share is that, of course, when we talk about 4G and 5G networks, we always correlate it to the consumer market. But there is also a developing use case of the LTE, and especially 5G, which is the private networks. And which I will talk about in a while about what is private network or private wireless network. And also from the industry, we are seeing that uh, the global industry share of private LTE or private 5G networks are continuously growing. And in terms of the industries eating up or contributing to that adoption is primarily described here in this pie graph here, which the top three are energy and utilities, manufacturing, and transport and logistics. So later on, I have 2 to 3 slides to discuss about what is private LTE and what's the difference between other access technologies such as the Wi-Fi. Yes. Okay, so in terms of evolution of technology, as I have said, in the next 3 years, there will be an expectation of more deployments on 5G. But in terms of the technology roadmap, in terms of wireless communication, so here, what you can see right here in the screen is a 10-year roadmap forecast combined from industry and also from Nokia forecast as well. What we're seeing is that there will be around five major roadmaps in terms of how 5G and existing 4G networks will evolve. So, and all of these are of course hinged to the global standardization body, the WRC, and also in line with the ITU standardization body. And what we can see right here is that 5G will still be, or in the next couple of years, 5G will be the mainstream technology that operators will focus on. And also the adoption of 5G enterprise and private wireless networks for public safety, defense, utilities, and railways, and other segments will also begin to take an upward trend. And in terms of the use cases, if you ask what are the other use cases of 5G, what we can see is that there will be also an adoption or the realization of such use cases, such as, of course, fixed wireless access will be there, AR, VR, augmented reality, and virtual reality, to name a few. And for that to happen, operators will likely to begin to adopt standalone 5G and also to reform their existing spectrum assets. So it has already begun. Most of the operators have started to reform or to sunset their 3G as an example. And also with that, as we advance in the next couple of years, we will see that more 3G sunsetting will happen, and also the development of refarming from 4G to 5G spectrum globally. Yeah. And also, of course, one of the key highlights of this session is how do we relate all of these technologies in terms of Cloud RAN, or what we call hybrid RAN and the Open RAN. So I would just like to highlight that Open RAN has its own standardization, completely different or completely separate with the 3GPP standards. You may have already known about this, but there is actually a significant correlation of how do these two technologies, O-RAN and 5G, will work together for the development of the cellular network in the future. And again, all of these technologies are being standardized through a standardization body, which actually leads me to my next slides here. Now also, as part of what's happening in the industry, so what has recently happened in the cellular network world is this very interesting event that happened last December in Dubai. So the ITU, the World Radio Conference, was held in Dubai. It was attended by around 115 countries and around 3,000 participants around the globe. So what happened basically there was the definition of the new bands to be used for 6G. So it's being done already. This is again another momentous event in terms of the cellular industry, where 6G spectrum development has already begun. And initially, in terms of the spectrum, they have initially considered the 6 to 7 gigahertz spectrum allocation, and around 700 megahertz spectrum endorsed for IMT use in WRC 23 in Dubai. And this primarily is being planned to be allocated for, of course, for more 5G and advance and development, and also 6G growth. And again, this has initially been identified by 3GPP as a new TDD band, that now what they call N104. So they have actually allocated initially N104 that allows for early deployment of harmonization or harmonized 6G capable radio environment. So that's actually what had happened last December, and this is in line with the timeline of WRC or ITU standardization body for the standardization freeze that they are aiming to happen by June of this year. And later on in 2027, the WRC 27 will take place in 2027 to formally lock in the standards for 6G. So one good thing to note here in this topic is that 6G spectrum development is ongoing, and it's something also related also to 5G and 6G, because I think most of the people's confusion is that once we have a new G or new generation mobile network, the older Gs comes to an end, right? But also that the reality is that as we go along in terms of the new generation mobile networks, it has something to do with the previous G, like what happened with 5G, right? Initially, there's this NSA that hinges the deployment on 4G, and it is likely to happen in 6G moving forward. Yeah. Okay, in terms of 5G evolution, again, 5G standalone is still the platform for future evolution. So the end ambition for 5G is to go standalone, meaning to operate in the to operate as a standalone network, exclusive of 5G technology, whereas compared to hinging the technology to LTE. And again, SA needs no LTE transmission and no LTE mid-band anchoring. So meaning to say, the true ambition of 5G is for the networks to adopt the standalone mode or the 5G SA mode on top of their existing NSA. And this will really unlock the use cases across the verticals, such as the enterprise, such as in terms of logistics, airports, manufacturing, mining, oil and gas, to name a few. And again, 5G advance will still happen, and also we're still forecasting in the horizon. It will still be, it will again unlock future use cases. Again, to name a few, in terms of entertainment, media, and also gaming, and also from across industries alike. Yeah. So having said that, I think one of the major concerns right now is also for the operators. One of the major questions from operators is how do they monetize their 5G? But I think it's mostly in terms of how operators adapt, or how do they be more creative in terms of offering services. And it's more of preparing the network to 5G use cases. And again, 5G standalone is still the way to go, as we see it, as it will deliver a more improved throughput and latency requirements, and more consistent latency towards the services. And as we're also seeing right now, there are two clear 5G standalone opportunities, which is the fixed and private wireless networks, and also coupled by the enhanced network slicing technology that we have in the core network. So in terms of 5G, more emerging opportunities that we can see are the reduced capability. So there are a lot also going on in terms of testing of RedCap around the globe, extended reality, and also private wireless expansion with slicing. In terms of private wireless network, so the typical deployment of the network that we have today is for the consumer network. Now, when it comes to private enterprise or private companies demanding their or requiring their private network, so at the moment, what we can see is that in an enterprise setup, it could possibly be a 4G or 5G. They are possibly served by a 4G or 5G network from the consumer or from the public network itself, coupled with the deployment of course, the Wi-Fi connectivity, and that basically resides in the office environment, and also serves typically the employees or the mobile services, the typical applications that a consumer uses in the market. But in terms of industries or enterprise customers requiring business and critical applications such as industry automation, port operations, manufacturing, industries in the oil and gas, there are applications that require mission critical, or we can categorize as mission critical applications. So these are basically on top of the IT requirements, or different, or what we call the OT requirements, or operational technologies. So in this sense, in this application, this is where a private wireless network is useful, and this is how we see as a technology supplier or vendor the major improvements that a private wireless connectivity can bring to the industry itself. So just to differentiate what a private versus a public LTE network is, or even public private 5G. In this picture here, you can show on the left that, or on the right, this is a typical public LTE deployment where there is a centralized core. Of course, this is hosted in the customer, in the operator's network, and the coverage in the customer premise is served by a public macro cell site, right? And this typical setup, of course, is when you have the core network far from the site itself. Of course, it introduces more latency. It also poses less security, and maybe customer data can stay elsewhere. And of course, there will be SLAs, but it's typically non-guaranteed. And of course, there will be unpredictable network maintenance issues. Now, some of the customers or enterprise customers operating with mission critical activities require less latency. To give an example, a port operator here. Of course, a port operator, some of the port operators that we engage at the moment, they are now beginning to see, or they're now beginning to evolve their existing IT and also network infrastructure in terms of their network operations. They now require connectivity in terms of their IoT devices, and how do they automate their overall operations. And that requires less latency and, of course, guaranteed bitrate and throughput and quality of service. And even more so, more and more enterprise or big companies now require a more secure networks or customer data. They prefer to stay on their premises. And again, there's also a big requirement on SLAs and network maintenance requirements. So this is where private networks become useful and become applicable for those segments that require these kinds of requirements. And the top 5 industries that is there that is beginning to slowly migrate to private wireless applications or private wireless network is, of course, in manufacturing. We see that in Japan. There's a number of manufacturing companies already adapting to deploy private wireless networks. In ports, this is also applicable in Philippines. We have been engaging with some of the local port operators. They're now exploring, to migrate their operations to full digital and also private. And also from global perspective, we see a lot of requirements or a lot of commercial deployments from aviation, mining, oil and gas industries. So these are the top 5 industries for private wireless applications. So in terms of the comparison, or we may actually begin to compare what's the difference between Wi-Fi and the private wireless. So since private wireless is deployed using LTE or 5G, so there's a lot of differences or point of comparison that we can take. So this slide summarizes the main difference of using LTE or 5G technology compared to Wi-Fi. So in terms of high data rates, low latency, yes, Wi-Fi can serve it. Even so, LTE 5G. But all of the items here, some are, or most of the items are can only be handled or can only be delivered by a cellular network such as 5G. So most of them are related to mission critical connections. Say for example, the cranes, the RTGs or the rubber tied gantries in the ports, where they actually load and unload huge containers on the trucks. So what we are getting from our port customers is that Wi-Fi can actually serve the coverage requirement, but in terms of the real time handover or the real time connection, there is actually a pressing issue in terms of using Wi-Fi connectivity. And again, some of the factors that that contribute to the usage of LTE and 5G in private wireless networks is also in terms of coverage. So, when we use base stations providing LTE and 5G, it radiates more power compared to Wi-Fi access points, and also it can cover deep indoor scenarios and also applications for that matter of use case. Yep. And also a slide showing a more detailed comparison of how Wi-Fi 5 and version 6 compared to private wireless connectivity. So it's very clear that in terms of capacity, private wireless networks can handle more connections on a single small cell compared to 100 of Wi-Fi. Coverage, as I mentioned, this is being driven by the intrinsic power capability of cellular-based base stations compared to Wi-Fi access points. And again, in terms of mobility, 4G and 5G technology can actually handle or can actually provide mobility functions to the access points or to the end devices connected to that technology. And again, I think one of the most important uh, uh, point here is the latency or the latency, where 4G and 5G can really bring down the latency, which is very useful for industry applications. So this is a typical deployment of a private wireless network. So what you can see here is a picture of a typical port operator operating in port terminals. So as you can see here, there are now applications using manned and unmanned vehicles, trucks. Especially this is applicable in Europe, but in Philippines, we will still have to see how do they migrate to this type of applications. But the most common use case that we have been engaging with is for this local Philippine port operators to connect their IoT devices initially to the private wireless network. So the main requirement for the port operators here is for them to have their own network and also for productivity. So they want to be more efficient in terms of monitoring their operations and also how they can actually leverage on the wireless network to better monitor the operations holistically in the port. So this actually, as an example, the video analytics, as you can see right here. So with the huge amount of processing required for the video analytics, it definitely requires higher throughput and of course the lowest latency that they can get in the technology that they have. So it's really important that whatever the technology is being deployed, it can handle those major factors such as the bandwidth and the throughput requirements for the overall operations. So just a summary in terms of adaptation of the private wireless. Globally, private wireless networks uh, have been deployed. It's not a new in 2024, but what is actually going to be the prime technology for private wireless? It's really 5G. So there have been deployments or early deployments from other countries of private 5G, but most of it as of now is on private LTE. Now, you may ask what's the difference between private LTE and 4G? So basically, it's the technology, and 5G, of course, can deliver the three most important improvement in terms of latency, throughput requirements, and also capacity. So the more devices that you connect to the private wireless network, it will require bigger bandwidth, which actually 5G can provide. Yeah, and this pie graph here shows that around the globe, the top industries that have adopted private networks, the number one would be the manufacturing, which constitutes around 26% of the global private wireless sector, followed by transportation and logistics, which includes the port operators, airports, and aviation industry. Yeah. And based also from our partner researcher is that in terms of the private cellular networks or the demand from the industry, it will actually continue to grow in terms of the 5G use case. So mean to say, the network spend of the companies around the globe we're likely to focus on 5G deployment instead of LTE. As you can see here, by end of 2025, there are likely more private wireless on 5G investments compared to LTE. Yeah. Now, another update on Cloud RAN and O-RAN. Again, in terms of radio access technology, this is an update where we are now beginning to see a different kind of deployment in terms of the RAN component of the network. So, in terms of Nokia solution, this is actually an implementation where Nokia supports any RAN, what we call any RAN. It's basically supporting radio access network on any architecture, whether it be on CSP, on public cloud, with web scalers as well, as you can see in the slide. Compared to typical radio access deployment, where you have the basebands, the baseband servers, the radio as bare metal. This is now an improvement or an update where the radio can now be deployed in partnership with AWS, to name a few, IBM or Google Cloud or Microsoft Azure. So this is basically going or cloudifying the RAN network in general. And this contributes, or this brings about, high energy efficiency, where you can actually, it's making use of the cloud infrastructure as the resource, as a central resource provider for the RAN network. And also, of course, it actually provides optimum scaling, where you can actually scale up the capacity even more faster than deploying it on bare metal approach. Yeah. And in terms of the O-RAN update, I think I would also like to share, and as I've been sharing also with my colleagues in the industry, that O-RAN is on track. What we have seen from the O-RAN Alliance is that there have been a lot of O-RAN multi-vendor verification that has been concluded last year, and will still to continue in the next coming years. And from this graphical representations here, in terms of O-RAN, there are actually around 11 working groups when we talk about the O-RAN Alliance. So in Nokia, we are happy to share that out of those 11 working groups, we are co-chairing or co-leading two of, or we have active contributions on the two working groups in here. And working groups number 3, which is the near real-time RIC or RAN intelligent controller. Number 4, open front haul, which is the very popular working group in O-RAN. And this is also what I want to highlight, that when we talk about O-RAN, of course, the typical subject that comes to our mind is the mixing and matching of baseband and radio from different suppliers. That is one of the most active working group in the O-RAN Alliance, but also to share that there are actually in reality around 11 working groups. So most of the vendors also concentrating on these other working groups. To name a few, we have the Open F1, the other interfaces of the O-RAN architecture, the cloudification and orchestration, white box hardware, stack reference design, Open XL or transport part of the O-RAN, O&M, and security. So in terms of O-RAN, there's a lot of working groups to focus on. But I think from the industry perspective, also being participated by operators alike, Open Fronthaul, of course, is the one that is actively developing and with the most contributions from the telco operator side as well. And just to also to complement that slide, so when we talk about ORAN, it's composed of different layers. So in terms of the architecture, of course, as you may have learned from the previous sessions of IORA and USA. Also, just to show it here that in terms of the working groups, they are realized into this several interfaces. So again, the most common one here or the most popular ORAN working group is the open front hall, where you can actually use different basebands with different radio units in the market. And as I said, vendors such as Nokia are also contributing and focusing on other layers of ORAN. Some of it are the SMO, the service management, and the RAN intelligent controller. So as we have been also preaching in the market that the RAN intelligent controller will be a vital part of the total ORAN architecture in the future, because this is where the development, the software development will come in. So unlike to traditional way of doing software features in the radio access network that is only being controlled by the radio suppliers themselves or being done by the radio suppliers themselves, with the RIC interface of ORAN, this will actually open up the software development to the public, or not really to the public, but to a bigger industry audience of developing software features for the cellular mobile network. So imagine this as a Google Marketplace or an Apple App Store, where even small players or small companies are able to develop applications or software for the radio access network itself. So this is a very interesting layer of ORAN for that matter. Yep. And also, this is a slide showing what are the developments of ORAN in terms of the operator. So I think it's always important to learn and to understand how ORAN progresses in terms of verification or integration with the telco operators themselves. As at the end of the day, of course, the main objective of ORAN is really to integrate in a multi-vendor scenario. So just to share, these are the latest ORAN progress. So Nokia has been the pink circles here denotes that the verification denotes open front hall integration or verification with operators, and the violet box here denotes the RAN intelligent controller use case. So in general, Nokia's RAN vendor supplier has verified integration with these operators in the market. You have it there, Deutsche Telecom, where this just happened last December, where Deutsche Telecom partnered with us and also Fujitsu to begin a ORAN commercial deployment in the northern part of Germany. And also what you can see right here are some integration in terms of other ORAN players in the market, such as Fujitsu, Samji, to name a few. Yeah. So in terms of to wrap up this session, in terms of the main key takeaways of the market trend or the market update for this quarter or for this session, what we are seeing is that in terms of ORAN, the ORAN is on the stage where it is on continuous standardization and development, with service providers globally slowly positioning to deploy. So it's more of the industry mix or the market adaptation of the ORAN depending on the market. So also to share that since last December, there has been a lot of ORAN press releases with the major operators around the globe. So what we see is that it's beginning to take an upward trend, or the adoption of the ORAN technology, especially with the first world, or the biggest telecom players around the globe. And again, in terms of the market position that we have in terms of radio access network, what we see is that 5G technology will still continue to be there. It's mostly on how do we define the use case, especially what use cases are really tangible, what use cases can really bring business potential to the operators. And also, again, it's also not just about the business side of it, but also to improve how the consumer, us, the subscribers, can really take advantage of this technology, such as 5G, and moving forward, the ORAN and 6G. And again, for 2024, what we see in the market that's happening is that operators will continue to adopt Cloud RAN, or cloudifying the radio access network. And also 5G standalone has yet to prove its a position in the overall architecture of 5G. And again, private wireless. So we see that private wireless will really be one of the concrete and real use cases of 5G, and that can bring improvement in the overall cellular network industry.